Welcome to the Canadian Beef Cattle Podcast, presented by the Beef Cattle Research Council, the most popular content from beefresearch.ca, available on the go. Before we get into this week's episode, a quick message from the BCRC. Ensuring newborn calves consume colostrum is one of the most important management strategies cow-calf operations can implement to promote healthy calves. Colostrum provides essential antibodies to a calf with virtually no immune system. Colostrum also contains fats, vitamins, proteins, and other immune cells essential to provide the calf energy, warmth, and the local immunity it requires to thrive in the first few days of life. It is crucial for producers to observe newborn calves to make sure that they have received colostrum and to intervene if necessary. Learn more about handling colostrum by clicking the link in the show notes. This episode is titled Microbiome: The Little Things May Mean a Lot, and features the BCRC Science Director, Dr. Reynold Bergen.
This Research on the Record article originally appeared in the January 2025 issue of Canadian Cattleman magazine. It's been reposted on the beefresearch.ca site with the publisher's permission. Today we're going to talk about the microbiome. The little things may mean a lot. A microbiome is all of the microbes, so the bacteria, the fungi, the viruses, and all of the genes that they carry. So all the microbes that live in a particular environment, plus how they all interact with each other. Now, animals have several microbiomes. There's an oral microbiome, that's the mouth and all the microbes in it. And there's also nasal and respiratory and rumen, intestinal, vaginal, rectal, and skin microbiomes. And those different microbiomes interact with each other as well as with the host animal. It's all very complex. Animals are actually outnumbered by all of the microbial tenants in their body. I like to think of myself as human, but most of me isn't. If I could separate all of the cells in my body into a pile of human cells and a pile of microbial cells, the pile of microbial cells would probably be the biggest. And that's also true of you. And it's even more true with cattle because the rumen and the large intestine are really giant microbial fermentation vats. Now, the key point about the microbiome is that the microbes and the animal cells interact with each other as well as their shared environment. And that's most obvious when microbial populations are imbalanced. So things like bovine respiratory disease and rumen acidosis and bloat and liver abscesses are all examples of out-of-kilter microbiomes. Dietary changes can temporarily shift microbial populations, but permanently changing an established microbe is very challenging. And that's one of the reasons why so many commercial probiotics that are intended or marketed to fix or improve the microbiome need to be fed continuously, and they often have inconsistent results. Because it's a lot like human social groups. If a stable social group or community has been established for a long time, it's really hard for an outsider to move in and fit in and get accepted. Same with microbiomes. So when it comes to microbiomes, it may be more effective to intervene early in life while the various microbes are still sorting themselves out. So kind of like kids who are playing together 5 minutes after seeing each other for the first time. And so that's where much of the microbiome research is currently focused. So Nilusha Malmuthuj, who's with Agriculture Canada in Lethbridge, and Lilu Guan, who's at University of British Columbia, recently reviewed the state of cattle microbiome research, and the paper's linked in the online version of this article if you wanted to read that for yourself. So what they did was they reviewed and summarized the scientific publications about how the microbiome develops in humans and in lab animals and in livestock. There's undoubtedly differences between species, but there are also common principles that apply across species. So what they learned was, well, for starters, the microbiome begins to develop much sooner than I ever thought it did. It's kind of obvious that exposure to the environment early in life is going to have an impact, and they've seen that. So research comparing mouse pups that are born to mother mice that had a normal microbiome, when they compare those to mouse pups that were born to germ-free mother mice, they found that normal development of the mouse's immune system depends on early colonization of the microbiome. Now, newborn calves are obviously exposed to a huge range of microbes from both the dam, especially the udder and the colostrum, as well as the environment that they're born in. In the first few hours of life, colostrum that they drink bypasses the calf's rumen and travels directly into the small intestine. And the intestinal lining has a lot of specialized cells, and some of them absorb maternal antibodies from the colostrum to protect the calf from disease. And other specialized cells in the intestine provide sites where the microbes can begin to colonize. And the interesting thing is that those microbes appear to help the calf absorb those maternal antibodies from the colostrum better. And like the mouse studies, it also appears that the microbes and the calf immune system each influence how the other develops. Now, exactly how this happens isn't known yet, but it seems likely that the calving environment is going to play a role. So think of an open pasture compared to a calving shed. There's going to be different microbes there. Or calving season, frozen ground versus mud. Or pen conditions, sloppy versus dry ground. Or a well-bedded pen. All of those things will affect the microbes they're exposed to, as well as how the microbiome and immunity develops in the calf's gut and respiratory tract. But we can back up a step further, and even the calving process itself influences how the microbiome develops. So in a normal calving, the oral and respiratory microbiome of the calf gets seeded as that calf passes through the birth canal. They call them calving problems for a reason, but it turns out that difficult calvings might cause even more problems than we already knew about. In humans, prolonged labor increases the likelihood of microbiome-linked disorders in the offspring. So again, in humans, prolonged births are linked to things like allergies and asthma and autism and colorectal cancer and diabetes and diarrhea and eczema, inflammatory bowel disease and obesity. Things that turn up way later in life can be linked to difficult births. So time will tell whether calving problems can similarly predispose calves to later problems like scours or reproductive disorders or BRD or liver abscesses. But again, research is looking at it. But the microbiome starts to develop even farther back than that. So the foundation for healthy calf microbiome starts long before birth in the pregnant cow. So again, in humans, studies have shown that the levels of fat or fruit or vegetable oil or specific dietary fatty acids that a pregnant mother consumes can impact the immune system, the microbiome, and health outcomes, especially allergies, of their children. In pregnant cows, research has shown that the vitamin and mineral program the cows are on can influence the size and microbial composition of the gut microbiome that the calf develops after birth. And that might happen by influencing the microbes that are found in the dam's colostrum. And the pregnant cow's diet can also impact how the calf's immune system responds to vaccines, both before and after weaning. So what's the bottom line here? Well, stay tuned. Ongoing research will clarify whether these measurable changes that researchers see in the composition of the newborn calf's microbiome actually have practically and economically meaningful impacts on that calf's long-term health, growth, fertility, or longevity. So what does this mean to you? Well, we're still waiting for a lot of answers, but in the meantime, don't forget to use what you already know. Pay careful attention to your winter feeding program and your cow's body condition scores. Paying attention to those things and optimizing them will both help the fetal calf develop normally. It'll reduce the risks of calving difficulty. It'll produce high quality colostrum with lots of antibodies. And all of those things will help give calves a good start in life. Some calves are still going to need help at birth. And one of the things we know is that over half of all pre-weaning calf deaths happen in the first 24 hours after birth. BCRC has developed a bunch of Calf 911 resources to help you get those distressed calves through that critical period. To my way of thinking, at today's prices, the time spent to find and save a few extra calves is probably worth the effort, even if you choose not to keep that cow in the herd or keep her heifer calf as a replacement.
Thank you for listening to this week's episode. You can find all relevant links and information at beefresearch.ca or in the show notes. The Beef Cattle Research Council is funded by the Canadian Beef Cattle Checkoff and strives for excellence in the production of Canadian beef, cattle, and forage through research, innovation, and extension. Tune in every Tuesday as the Canadian Beef Cattle Podcast delivers straightforward insights, expert information, and a wealth of practical knowledge for Canadian beef producers. Subscribe now.